Assalamualaikum warahmatullahi wabarakatuh. Good afternoon for everybody. Thank you very much for the opportunity. I am Muhammad Masan Mahasin. I will present our papers with title Development of a Modified Unit-Based Image Segmentation Architecture for Brain Tumor MRI Segmentation. This is a collaboratory research with Prof. Agus Naba, Mr. Komsin Slisa Widodo, and Prof. Yun Yunawati from Radiology Department. So I am from Physics Department. The background of this research is brain tumor is a deadly disease, so it is necessary to do a precise and accurate diagnosis. In the process of diagnosis, it is done by using a radiographic device, namely MRI or magnetic resonance imaging. There are several segmentation methods that can be used. In the study, we developed an MRI image segmentation method with artificial intelligence, that namely UNET. So in the right is MRI device or MRI machine, and in the left is the image from MRI machine. So the image is slice per slice from the patients. In the example, this is MRI image from brain patients. This is how MRI works, or magnetic resonance imaging. From the name MRI is using the resonance of in the magnetic resonance from the patient's body. So MRI takes advantage of the magnetic properties in the patient's body to obtain image. So this is the magnetic source. This is the patient, and in the bottom is magnetic field strength. So the MRI device is give a patient with a little magnetic impulse. And this is the example of MRI image obtained when a patient makes a diagnosis using an MRI. This is from brain MRI image. So the image is slice per slice from the patients. After this, we can. This is the doctor or the radiologist using this for diagnosis the patient. For this case, is for brain tumor. We can segment the MRI image using image processing. So what is image processing? Image processing is a method to perform some operations on an image in order to get an enhanced image or to extract some useful information from it. So image processing is we process some image with some numerical process. There are several segmentation methods. In this paper, we use from unit architecture. This is unit architecture. This published in 2015. Unit architecture is image segmentation architecture that use some convolutional layer and some pooling and uppooling layer. So if we see this architecture, we can see that this architecture is symmetric from the center to the right and to the left. This is the input image, and this is the output. From that unit, we modify with new CNN architecture. This is the main layer from unit. The first is pooling and unpooling. Pooling is for decrease the matrix size, and after that, unpooling is increase this matrix size for some specific pixel value. This is the input, and this is the output after several pooling and unpooling layer. We can see that the output is just the mask from the image. And this is the UBNet V1 architecture. This is a CNN-based architecture for classifications, and the UBNet V1 architecture is developed for classify X-ray image for COVID-19. So this is specifically developed for X-ray image. We use this to modify this unit architecture, and this is the result: unit-based UBNet V1 architecture. This is image segmentation architecture based on UBNet V1. So what is the difference from the two architecture? The main difference is we can see in the total parameter. In unit UBNet, the total parameter is more low. This is can interpret that the computational cost for unit based on UBNet is more low than UNET. So this is more effective to apply in the real case. After this, we can use that UNET OBNet model for MRI segmentation. We get the data from this. This is the open source dataset. If we see the dataset is like this is the input, the MRI image, and this is the label. This is for training the model unit based on UBNet. Yeah. Oh yeah, and we have six input size from 512, 256, 128, and until the very small size, 16 and 16. And this is the loss graph in training model. We can see the more value is more good. And this is the output for the segmentation result from training. This is when the image size input is 16. This is for 32, and this is for 64. We can see that the more low size image, the segmentation result is more roughly, and this is for 512. We can see that this is more precise. And this the comparison of accuracy and loss with different input size, we can see that there are no significant difference for accuracy and loss from the different input size. And this is, I think this is good because the accuracy is almost 100%. This is we also built the GUI or graphic user interface for using the model easily. And this is the initial view, and this is the result when we doing the segmentation task with this GUI. And I'm also have the video for demonstrate this. This is our GUI. Sorry. We can choose the image input, and we can choose also the segmentation output. We want the original segmentation or the binary with some threshold. This is, we can click the input button to input the MRI image, and this is the segmentation result. We can doing segmentation MRI image in no more than 2 seconds and accurately. We can see that increase the input size will increase the accurate of the segmentation result. Yeah. And we also can change the output for binary segmentation. And all of the segmentation is done no more than 2 seconds. Yep. So the conclusion is the unit OBNet image segmentation architecture can be used to process brain MRI image and perform segmentation well. Change in input size have no significant effect on accuracy and loss in unit OBNet model training. However, it is still quite influential and a visual appearance of the segmentation result. The smaller the input image size, the coarser the segmentation result. Meanwhile, the larger the size of the input image used, the more detailed the segmentation result will be. And the GUI that was built can work well and make it easier to segment the brain MRI image for low glioma patients or for tumor brain patients. The time required to segment the image is quite fast, under 5 seconds. So maybe that's all from me. Thank you very much. It is an hour for me to speak here. Thank you very much.